All right, ladies and gentlemen, in today's class, we're going to be talking about simplifying radicals. And what that looks like is we're going to be trying to understand how to simplify something that looks like this, the square root of 108, or something that looks like this fraction, the square root of 15 over 49. We are going to do some problems with numbers, and then we're going to do some problems that contain variables. Now, in order to understand what we're doing today in today's class, we need to kind of recap what we did in last class and talk about exponents. We saw in exponents, if we multiply bases together, we add the exponents. So we saw that x squared times x cubed is really adding powers together, and that would equal x to the fifth power. So we saw positive exponents. We saw x to the fifth power divided by x to the eighth power, where we need to subtract exponents, and 5 minus 8 would be x to the negative third power. And we've seen positive exponents, we've seen negative exponents. We talked briefly about anything raised to the 0 power and how that equals 1. But in today's class, we're going to be talking about this situation where we have an exponent of 1/2 and what this looks like. Because what this equals x to the 1/2 power is really the square root of x. And let me kind of explain where this comes from and why this is true. So you and I know that, say we wanted to take 7 squared. Right? If we wanted to, 7 squared equals 49. And if we take, let me move my paper. If we take the square root of 49, we know that that equals 7. Because 7 times 7 equals 49. Now, if I take 7 squared and take the square root of that, well, I'm telling you that this really equals 7 squared to the 1/2 power. And something that we also saw in last class was when we have this situation, we don't add the exponents, we don't subtract the exponents, we multiply the exponents. So if we have an exponent of 2, which is really 2 over 1, and we multiply it by 1 over 2, 2 times 1 is 2, 1 times 2 is 2, and 2 divided by 2 is 1. So if we were to simplify this, then these exponents create an exponent, a power of 1. So 7 squared to the 1/2 power is simply 7 to the first power, which is what we know to be true because the square root of 49 equals 7. So when we're dealing with square roots, we're really dealing with an exponent of 1/2. So that's how that ties into exponents and what we're doing, what we did in the last class. When we're working in these problems, I want to share with you the basic idea. The first thing that we need to do in order to simplify these is we need to find factors that are perfect squares. So let me write that down. We need to find factors, and remember the factors are the number that equal the product. So what numbers can we multiply to get 108? Find the factors that are perfect squares. Well, now you're asking me, what's a perfect square? Let's talk about that. So let's just look at the numbers 1 through 12. So if we square these, if we take each one of these and raise it to the second power, we're going to end up with whole numbers. 1 squared is 1, 2 squared is 4, 3 squared is 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144. Since the square of these numbers is a whole number, these 1 through 12 are perfect squares. So we're looking for numbers that we can easily take the square root of and get a whole number. So let me move this over so we can see this. Okay, so if we want to take the square root of 108, or we wanted to simplify this, we need to find what numbers out of here we can multiply in order to get 108. Well, 49 times 2, that's almost 50. So 50 times 2 is 100. That's too much. 64 times 2 is something like 128. So that, I'm sorry, 49 times 2 is 98. That's not enough. 64 times 2 is 128, and that's too much. So these numbers really aren't going to work for us. So let's try 36. So take your calculator. We can say 108 divided by 36. Oh, and that equals 3. So I know that 36 times 3 is the same thing as this 108. So the square root of 108 is the same thing as the square root of 36 times 3. When we're simplifying, what we can do is we can separate these factors into, and put them under their own radical, put them under their own square root, like this. So let's let me just show you that this is the exact same thing. So the square root of 108 is the same thing as the square root of 36 times the square root of 3. So let me show you where the square root button is on your calculator. The square root button is right here. And in my calculator, it's blue, which means I need to use the second button, second square root, 108, and that equals 10.39. So let me do that. Let me do this one and show you that it's the exact same thing. Second square root, 36. Now you see my cursor is still under the square root sign, so I'm going to tab over, and that ends the square root, so I'm now outside of the square root symbol, times second square root 3. I can enter. And look, it's the exact same thing. So these do in fact equal each other. Well, this is good news because I know what the square root of 36 is. It happens to be 6. Now I could type square root of 3 into my calculator and get a decimal, but I don't want to do that. Just like sometimes we want to leave a fraction as a fraction so that we don't have any rounding errors and we don't have a lot of decimals, we want to leave this as a square root. 6 times the square root of 3. And let me just show you that 6 times the square root of 3 is the same thing as the square root of 108. So 6 times second square root of 3, enter, is 10.39. So these are exactly the same. So this is the simplified version. This is what we need to do in today's class. We need to get the simplified version. I can't take any more numbers outside of the square root. Let's do example number 2, and then we'll do some practice problems together on the board. So for example number 2, we have 15 over 49, and we're going to take the square root of the whole thing. Now when I've got a fraction under the square root, just like I separated the factors here, I can separate them here. So I can write it square root of 15 over the square root of 49. Now I know the square root of 49. I like that. That's 7. So that's going to be a good answer. Now is there anything that is there any even numbers that I can take out of 15? Well, it's not 5 because that's 25. 4 squared is 16. That's too much. 3 squared is 9. That's not enough. The only factors of 15 are 1 and 15, and those aren't perfect squares. 3 and 5, and those aren't perfect squares. So I can't do anything to this. I cannot simplify this. So this is going to be the square root of 15 over square root of 49 is 7. And this is going to be my final answer. So as we're working today, as you're working through these problems and when we're working through these problems together on the board, you're going to see that we're going to be looking for perfect squares. We're going to separate the factors out under their own radicals, and then we're simply going to take the square root of the perfect square, and that's going to be our simplified answer.